Assalamualaikum, we are from Group 16 are going to present our Data Communication and Networking final project. Our group members are Muhammad Syami bin Muhammad Taib, Nurul Anis binti Ahmad, Farhani binti Ahmad Harazi, Nurul Atikah binti Muhammad Deni, and Wanur Maisara binti Muazzali. There are three parts of this project, which are OSI layer model, subnetting calculation, and TCP or IP configuration. OSI layer model. In this section, we are going to explain on how the data travels from the lecturer's computer to reach the ULAN system server, which is in the UTEM IT Center. There are a few network components that involve throughout the communication. In this case, the lecturer's computer is the sender and the ULAN system server is the receiver. The transmission medium is the physical path between the sender and the receiver. For example, twisted pair wire, fiber optic cable, and radio waves. In this case, the HTTPS are the protocol that are used to perform the lecturer activities to access the ULAN system. OSI stands for Open System Interconnection. It is a reference model that helps users to visualize how data are being transferred from one device to another device through physical medium in the networking system. OSI model consists of 7 layers and each layer carry out different network functions. The top layer is application layer. It is the closest to the end user, which is the lecturer. This layer will receive any forms of data like text, image, or video from the lecturer. In order to access the ULAN system, the lecturer needs to use the web browsers like Chrome. HTTP or HTTPS is the protocol that's being used for web surfing. Essentially, this application layer provides services for the network application to perform any user activities with the help of protocol. The next layer is presentation layer. This layer will receive data from the application layer. The data can be in the form of characters and numbers. This layer will convert those characters to machine-understandable binary format. This layer will also compress the data to reduce the number of bits of the original data. Thus, it can reach the server faster since the size is reduced. Before the data being transferred, the data will be encrypted to maintain the integrity of the data. On the sender side, the data is encrypted before reaching the destination and the data will be decrypted after reach their destination. In session layer, it will help in establishing or terminating connections to enable the sending and receiving process. Before a session or connection is established, ULAN system server will perform authentication to verify who is accessing the system. In this scenario, the lecturer will need to enter username and password. Once the username and password are matched and verified, a session is established between the lecturer's computer and ULAN system server. After authentication is done, authorization is being performed to determine if the lecturer has permissions to access the system or not. If not, then the lecturer will get a message you are not authorized to access this page. Transport layer controls the reliability of communication through flow control, error control, and segmentation. In segmentation, the data received from the session layer will be divided into small data units called segments. Each segment contains a source and destination port number to make sure each data reaches correct destination and sequence number to make sure the data are being sent in correct order. Flow control means it will control the amount of data that are being transferred. For example, if the lecturer wants to download a file from the ULAN system server and this server starts sending data in 50 Mbps, which greater than the lecturer's computer can process. With the help of transport layer, lecturer's computer can tell the server to slow down the data transmission rate to 10 Mbps and vice versa. For error control, if some data does not arrive at the destination transport layer, use automatic repeat request scheme to retransmit the lost or corrupted data. Network layer receives the data segments from the transport layer. The function of network layer is logical addressing. Lecturer's computer and the ULAN system server have their own unique IP address. Network layer will assign both sender and receiver IP address to each segment to form an IP packet. This is to ensure that each data packet reaches correct destination. The lecturer's computer can be connected to the ULAN system server in many ways. This layer uses protocols such as border gateway protocol and intermediate system to intermediate system to determine the best path. Data link layer receives data packets that contains IP address of the lecturer's computer and ULEarn system server from the network layer. Physical layer is done at data link layer where MAC addresses of the sender and receiver devices are assigned to each data packets to form a frame, which is a sequence of binary 0 and 1. At the bottom of the OSI model is the physical layer that represents the electrical and physical representation of the system. In this layer, the sequence of binary bits from the data link layer will convert it into signals and transmit it over a transmission medium. For example, copper cable if the signal is an electrical signal, or air in case of radio signal. The signal is generated based on the type of transmission medium used to connect the lecturer's computers and the ULEarn system server. In this case, since it is wireless, the signal is radio signal. Next is subnetting. In this session, we are going to show the calculation on how to identify the IP address that was assigned for a ULEarn system server based on the information given in the project scenario. For ULEarn system server network, the IP address same for the system is 192.168.0.0 and the subnet mask is 16. This is classic private addressing. The default subnet mask is 255.255.255.0. Because it has 30 different departments to fulfill the requirements of 30 subnets, so we need to borrow bits from the host to provide the number of subnets. In this case, it borrows 5 bits from the host. 2 to the power of n is 32 networks, so n equals to 5, where n is borrowed bit. This illustration uses the network formula to find subnets that are closest to 30. The new IP address theme is 192.168.0.0/21, so the new subnet mask is 255.255.248.0/21. The 248 is the number of places for host ID that earned by adding the decimal number in base 2. So add the decimal number to get 248. 248 equals to 128 plus 64 plus 32 plus 16 and plus 8. Next, to get the number of hosts per subnet, 2 to the power of 11, where 11 is 16 minus 5, equals to 2046. To get the difference between subnets, 2046 divided by 255, so we get 8 as the answer. Next is TCP or IP configuration.
In this part of the video, I'm going to show TCP or IP configuration on the server manually. In my case, my operating system is Windows 10. So first thing first, we go to our network settings, or you can simply go by clicking here, network and internet settings. Now after that, we click on the change adapter options. A window will pop up and you can see here a fully connected Wi-Fi. Right click on that and click on the properties. Now try to find Internet Protocol version 4 and double click. As you can see here, there are two options. Click on the use the following IP address so we can set our IP address, and based on the calculations, I'm going to type in the IP address, which is 192.168.80 and 5. Now for the subnet mask, it will automatically show the address. Then for the default gateway is usually your IP address but different number in the fourth octet. I'm gonna go with 192.168.80 and 1. Now for the preferred DNS server, I'm gonna type again the IP address, which is 192.168.80 and 5. What about the alternate DNS server? As for the alternate DNS server, I will simply use maybe Google DNS server, which is 8888. And after we have insert all the following address, just click OK and you are good to go. That's all you need to know. Thank you for watching.